So probability is kind of just an overall way to talk about what are the chances of something happening. But in the case of something, the probability of something happening that's a negative outcome, we usually call it risk. So when we calculate the probability of a negative outcome, like a heart attack, for example, there's no outcome, or there's no scenario where that's a good thing. We often refer to the probability as the risk. So for example, we talk about the probability of winning the lottery, which is a good thing, right? But the risk of getting struck by lightning, because I don't think that's ever a good thing. Maybe in superhero comics or something. Whenever you see the word risk, keep in mind that it's just another word for probability. So it's not like, you don't have to look back in your notes and say, oh wait, how do I calculate risk again? Risk is just a specific type of probability where it's just a bad outcome. So it's just renaming it, because it sounds better, right? Like a medication commercial on TV or whatever on YouTube, it says, the risk of you getting a heart attack is blah, blah, blah. It sounds like they care more, right? They probably don't really care. They just want to get your money, but it sounds like people care more, I guess. Researchers at the Physicians' Health Study in 1989 conducted a clinical trial to determine whether aspirin reduces the risk of heart attack. Researchers randomly assigned a large sample of healthy male physicians, 22,000 and some change, to one of two groups. One group took a low dose of aspirin, 325 milligrams every other day. The other group took a placebo, a sugar pill that looked like aspirin. Here are the final results. So we have a table here. Note that the categorical variable in this case the categorical variables in this case are, first, the explanatory variable is the treatment. So they're assuming that the treatment, the type, whether it's aspirin or placebo, will explain the results, the response variable, the medical outcome, whether was there a heart attack or not. So the question we're going to ask is, does aspirin lower the risk of having a heart attack? To answer this question, we compare two conditional probabilities. One, the probability of a heart attack for those taking aspirin every other day, and then two, the probability of a heart attack for those taking a placebo every other day. From the table, we have the probability of a heart attack in the aspirin group being, so let's see, wait, back at the table, okay. So we're trying to ask these questions here. Let's see. The probability of a heart attack for those taking aspirin every other day. So maybe we'll focus on one of those first. Just the probability of a heart attack for those actually taking aspirin, not those getting the placebo pill. That would be, okay, those taking aspirin. The very first row talks about those taking aspirin. The probability of a heart attack. Risk, I guess you could say risk of heart attack, which is equal to, same thing as probability of a heart attack. I hope you don't mind if I abbreviate it, HA, heart attack. It's going to be the total number of, in the aspirin group, heart attack, risk of heart attack for those that were taking aspirin is, okay, how many people got a heart attack, or had a heart attack that were taking aspirin? There were 139 out of the total number of, this is a conditional probability now, 11,037. So it's kind of like, I guess, probability of heart attack. I hope forgive my abbreviation. Heart attack, given that, remember that vertical bar we wrote? Given that they were taking aspirin. So once it's a conditional probability, we're kind of limiting ourselves to only looking at either one row or one column. So it's this division, and they've done it here. They got 0.013. That's the probability or the risk. Either way, you leave it like that. But in our minds, we can kind of move that decimal point over. I have a hard time really wrapping my mind around that decimal. But if I move the decimal point over, that's 1.3%. Now, keep in mind if there's a midterm or a quiz or something, and they ask you what's the probability, you're going to give them the actual decimal number. Percentages are just for us to wrap our minds around it, I guess. Okay, and then you also want to ask, what's the probability of a heart attack for those taking a placebo every other day? So that would be kind of the same calculation, but we're going to be looking at the second row. So how many of these people with this placebo had a heart attack? There were 239 out of the total here. Was almost the same as the previous total, 11,034. They did that calculation down here and got 0.022. So 2.2% versus 1.3%. That's a fairly significant difference, I would say. The results show that taking aspirin reduces the risk from 0.022 down to 0.013. So your risk was, without taking aspirin, it was 2.2%. But if you take aspirin every other day, it's 1.3%. We often compare two risks by calculating the percentage change. We calculate the difference, how much the risk changed with the new treatment, and divide by the risk when there is no treatment, or a currently accepted standard treatment. Here's the calculation of the percent change in risk for the aspirin study of the previous example. We take the two numerators, the 0.013 and the 0.022, subtract them. You get a negative number here. Let's see. You can barely see it. Hopefully you can scroll down on this page. Pause the video, scroll down on this page, and then see it. But you get a negative number, which means there's a reduction. Therefore, we conclude that taking aspirin results in, a 41% reduction of risk. As reported in the New England Journal of Medicine, the trial of aspirin for the primary prevention of cardiovascular disease demonstrates a conclusive reduction in the risk of myocardial infarction, is that right? Heart attack. So down below they've got a nice, and they've actually written out the formula for percent reduction of risk. It's a fraction, but in the numerator you subtract two things. New treatment risk and the placebo risk. So it's kind of those decimals or those percentages that we had, the 0.013 and then the 0.022. Those guys versus, and then divided by the placebo risk. So notice that the variable, let's see if I can do something here. Zoom in. So notice that there are kind of three variables here running around in this little formula, but the number that you're subtracting in the numerator is the same as the number in the denominator. So this number and this number are going to be the same. But the new treatment risk is a different number. So kind of an interesting, formula. In general, we are, what does it say here? In general, we are interested in determining how much a new treatment reduces the risk compared to the reference risk. The reference may be non-treatment, for example, using a placebo, or it could be an existing treatment that we hope to improve on. So we have percentage of reduction of risk is the new treatment risk, subtract the reference risk, divided by the reference risk. Either way, those two numbers, the rightmost number in the numerator and the denominator, are the same number.